Hi, good afternoon. These notes are on word problems for both surface area and volume. This should be page 119 in your notebook. So there's a few things that we need to take care of at the top. And these are your steps for working with word problems. So your first step is you're going to read the problem and determine the shape that you'll be working with. Number 2, you're going to draw the figure and label its dimensions. This is kind of optional. If you want to draw it, you can, if that helps you to see the visual, but really you don't have to in order to figure it out. Number 3, then you're going to decide if it's asking for surface area or for volume, and then you're going to use the appropriate formulas. And then step 4, solve. Don't forget that surface area is squared and that volume is cubed. So let's start with our first problem. If the box, so my shape is a rectangular prism, of cotton has a length of 44 meters, a width of 30 meters, and a height of 33 meters, what will be the volume of the cotton box? So this one actually gives it away because they already tell us what we're finding. Sometimes they would say how much would it take to fill up the space, and that would be volume. So we already know its shape, we know the dimensions, and we know that we're doing volume. So I like to draw the picture. I just do a quick little visual right here. And then I'm going to just label it. And with a rectangular prism, the labels actually don't really matter where you put them because you know that you're just going to do length times width times height. And multiplication has a commutative property, so I can just put them in pretty much in any order I like. So 44 times 30 times 33. And then when I type that into my calculator, excuse me, I get a very large number, 43,560 meters cubed. 43,560 meters cubed. And that is my volume of this box of cotton. All right, number 2, a swimming pool with a cylindrical base. So I know that my shape is a cylinder. Has a diameter of 21 feet and a depth of 5 feet. Find the volume. So we know it's a cylinder. We know we're finding volume because, again, they tell us what we're finding. And now we just have to draw the picture. Again, that's optional. Label the dimensions. My diameter goes all the way across. That's 21. And my depth is 5, which is how tall the pool is. So I know that for volume of a cylinder, it's the area of the base, so pi r squared, and then times the height of the cylinder. So I don't have my radius. I need to find it. Half of 21 is 10.5. So I'm going to use 10.5 as my radius, so 3.14 times 10.5 squared times my height of 5. And so my volume for this cylindrical pool is 1,730.925 feet cubed. If you want to round to the hundredths, you can. And there's your answer. All right. Number 3, explain why the volume of a cube with side lengths 1.5 by 1.5 by 1.5 cannot be 9 1/8 inches cubed. Draw the diagram to match this prism. So they do want us to draw it this time, so we're going to draw it. And we know that a cube has all the same length, so 1.5. So I can literally, in my calculator, do 1.5 cubed. Is that equal to 9 1/8 cubed? And we're going to see. So a lot of you sometimes don't know how to use this, so use the unit button to make your mixed number. So 1 and 1/2, or you could just type in 1.5. And then I'm going to square this. And how I'm going to square this, I'm going to choose the math button, which is right here. And I'm going to choose this choice right here, number 3, because that's going to cube my answer. So now my screen looks like this, 1.5 cubed. I press it and I get 3 3/8. So this is actually 3 3/8, which is not equal to 9 1/8 inches cubed. All right, number 4. Cameron makes a glass cylinder that has a diameter of 6 inches and a height of 5 inches for a friend. He wants to send it to his friend in a box that's a 6 by 6 by 5. He wants to put the cylinder in a box and wrap it with packing foam. How much packing foam does Cameron need? Okay, so think about this one. If I've got a box and I've got a cylinder and I'm putting the cylinder inside the box, well, I'm taking up space using the cylinder. So the foam is going to go around the cylinder, which means what I've got to do is find the volume of the box, find the volume of the cylinder, and subtract from it because that leaves the remaining space inside the box. So the box is easy because it's just a 6 by 6 by 5. And 6 by 6 by 5 gives me 180. The cylinder is a diameter of 6, so I'm going to use 3 as my radius, and a height of 5. So 3.14 times 3 squared times 5 is 141.3. So I know that my cylinder is taking up this much space. I know I have this much space to work with. So what's remaining for the foam? I just have to subtract. So 180 take away 141.3. And so my difference is 38.70 inches cubed. So that's how much space I have for my foam. Number 5. What is the volume of the Flatiron Building in New York City? The Flatiron Building is a 22-story building. Find the volume of each story. So what we're going to do is find the volume of this triangular prism, which we already know how to do, and then we need to find the volume of each story, so we're going to take this total volume and divide by 22. So we know that a volume of any shape is big B times H. Big B is the area of the base. Well, the base shape is a triangle, so we're doing triangle times height. So area of a triangle is base times height divided by 2. So this is 87 times 147, or 174, excuse me. So 87 times 174 divided by 2, so that's the area of my triangle, times the height of my building, 285. So 87 times 174, divide that by 2, gets me 7,569, and then I'm going to multiply that times 285. So here's my total volume. Okay, let's see, that's, so 2,157,165. So 2,157,165 is my volume for my total building. But then I want to know what is each floor, so I'm going to take this total answer and divide by 22. So my volume of each floor is 98,052.95 feet. So 98,052 feet and 95 hundredths. And again, I took this answer and I divided by 22. All right. Number 6. Find the difference in the amount of soup, and I think it's supposed to say soap, because that's soapy suds and that's clean, so I think this is supposed to say soap, of each container can hold. So we're going to find the volume here because we're finding how much it can hold, and so that's going to be filling it up. So find the volume here, and then find the difference. So 13 times 12 times 8. And this is 9 times 13 times 8. So 13 times 12 times 8, 1,248. And then 9 times 13 times 8 is 936. And their difference is 312 inches cubed. Okay. All right, number 7. Which locker has more storage? So we're talking about storage, which is filling it up. And basically this problem is just like this problem. So actually I'm going to have you try that on your own. And then a sandbox is 4 feet long by 2.75 feet wide and a ½ foot deep. How many cubic feet of sand can it hold? So again, we're talking about filling something up. So that is dealing with volume. So go ahead and try that on your own. Go ahead and pause the video, and then what I'll do is I will post the answer key in just a moment. All right, the answer to number 7 is 1,440, because for the first locker I got 7,200, and for the second locker I got 8,640. So the difference was 1,440 inches cubed. For the sandbox, I did 4 times 2.75 times 0.5, and I got 5.5 feet cubed. And then over here, number 9, I got C, because that is an example of volume, not surface area. Number 10, I found the surface area, and so I found the triangle, which I used 12 times 16, because remember, for a triangle, it's base times height, which need to be perpendicular to each other. So the 12 and 16 are the numbers, and then times or divided by 2 times 2, because surface area you're doing in the front and the back. And then I found the 3 rectangles. So this bottom one right here is a 20 by 24, so that's that one right there. This kind of slanted one right here, that's like the slide. That one is the 16 by 24, so this guy right here. And then that back one that you can't really see very well, that one is a 12 by 24. And that's where I got that. And then I found all the areas, and then I added them together and got 1,344 centimeters squared. Number 11, the surface area of a cube with side length of 1.5. Well, I found the area of one of the faces, which was 1.5 times 1.5, which is 2.25. And then I multiplied that times 6 and got 13.5. Number 12, I found we want to wrap it. So wrapping is surface area. So I found the area of all the faces, and I add them together and got 198. But then it says it's 5 cents per square inch. So then I took 198 and multiplied by 5 cents and got $9.90. So that's how I got A. Number 13, rectangular box, 10 inches long, 4 inches wide, and 6 inches tall was the surface area. So again, I just found the area of all the faces and then added them together and got 248 inches squared. How much paper would be needed to make a label for a can of dog food? Well, a can is cylinder. A label is only the rectangle that goes around the can, so I'm not finding the area of the 2 circles. So notice how I'm not including that. What I am including is just the rectangular piece, which remember is the circumference times the height of the cylinder. So circumference is pi times diameter, and diameter is 9, and then times the height, which was 14.5 centimeters. So I got 409.77 centimeters squared. All right, and then my last 2, you are painting the 4 walls of the gymnasium and the ceiling, so we're not including the floor. So I did 30 times 14, and I have 2 of those. That's 2 of my walls. I have 45 times 14. That's my other 2 walls. And then I have 45 times 30, but I'm only multiplying that times 1 because I'm only doing that for my, my ceiling, not my floor. Okay, so I got 3,450. I know earlier I said that volume, it does not matter which order you put the numbers in, but for surface area, it does matter. So make sure that you label those correctly. All right, then number 16 is very similar to number 15. A rectangular box top has no top. So we're only finding the area of the 4 sides plus the base, and that's what I did here, and I got 208 inches squared. All right, if you found any mistakes or if you have any questions, just please comment at the bottom of my video, and I hope you have a great afternoon.